Okay, we talk about empirical formula. What is the empirical formula? An empirical formula basically is a formula representing the simplest, right? This is the key word, the simplest whole number ratio of atoms, okay, of each element in a compound. Often in the exams it has been asked again and again to calculate the empirical formula, to calculate the molecular formula, and unfortunately the definition is still not clear for many students. Now what is a molecular formula? A molecular formula basically represents the actual number of atoms of each element in one molecule. Now what is the difference then? The difference is clear. It is the simplest whole number ratio. It is not a number, it is a ratio. So in terms of number it can be anything. For example, if I say it is in the ratio of 1:1:2, it means that it can be any number. It can be 2:2:4, it can be a multiple of 2, 5, it can be 5:5. The value could be 5:5:10, right? So these all ratios, again, if we look at the simplest whole number ratio, it would eventually be 1:1:2, and it can be any number. It can be a multiple of any number. Please don't err in this part. Okay, let's have a look at an example that how empirical formula is tested. There are two basic ways of testing empirical formula, right? In the form of grams when the weight is given, and in the form of percentage where the percentage is given. Okay, we have to look at either of these. Okay. Now hydrocarbon 2.51 grams and 0.48 grams of hydrogen. Now we are not sure which type of hydrocarbon it is, but we have to calculate the empirical formula. Now what we will do when we have to find the empirical formula, we have to follow some procedure, right? So first things first. First step that we call is to convert this mass into moles. So this is the first thing we are doing, and how we will be doing it? By dividing it by AR, right? Relative atomic mass. So for carbon, what would be the value? 2.51 divided by what is of carbon then? This is 12.0, 0.209 mole. Similarly for hydrogen, 0.488 and divided by 1.0, that is the AR, and this is simply 0.488 mole. Now we have to find the simplest ratio, and this is something that the math students will understand greatly, but it's not that difficult, believe me. And in the O-level math syllabus or in the A-level math syllabus, you have studied it in detail. What you have to do, you have to simply divide it by the simplest ratio, right? This is the smallest. Which one is the smallest? First things first. Is this the smallest? No, this is the smallest. So dividing both by the smallest ratio. So this is the second step that we have to do. Okay, the second step that we have to do is to divide by smallest value. I am writing it as value so that there is no confusion in it, right? Okay, so the smallest value amongst the two is what? Is this the smallest? No, this is the smallest, right? So dividing both the values by the smallest, 0.209, we are getting 1. Similarly 0.488 divided by 0.209, and we are getting a value of 2.33, right? Now this is the tricky part that you think, right? So ratio of C is to H is 1:2.33. Now if we look at it, what is 2.33? and how this can be converted into a whole number if I multiply both the equations by 3, because 2.33 multiplied by 3 would be giving me an approximate value of 7, right? So I am multiplying it both the equations by 3, so it becomes 3:7. So the carbon and the hydrogen is in the form of 3:7. So we would come to know this, and it becomes what? C3H7 is the simplest form. And if the relative molecular mass was given, now if this is the empirical formula, we are done with it, okay? But if what happens, the molecular mass is given to us, and the question says that the molecular mass is equivalent to what? It is equivalent to 86. Now what you have to do, when the molecular mass is given as 86, what we will be doing, we will be just using this thing in reference. C3 is what, and S7 is what? In terms of that, C3, if you recall, the AR of C was 12. Right? It was 12. So 12 into 3, it would become 36. Similarly, 7 of hydrogen, 7 into 1 is 7. So adding the two, we are getting a value 36 plus 7, that is 43. Now when the molecular mass is given 86, we would be calculating the ratio divided by the total mass of the empirical formula, and we are getting it 2. So multiplying this 3:7 by 2, we are getting 6:14. So according to this, right, according to this, our molecular formula is what? Yes students, it is C6 and H14. So this is the difference between the empirical formula and the molecular formula. Please don't make this mistake in the exams, please.